The question we are solving now belongs to test series 11. It is of control system subject. In specific, it belongs to Nyquist analysis. Please note that this is a linked answer question. As per the question, the open loop transfer function of a unity negative feedback control system is given as g of s multiplied by h of s is equal to 1 by s plus 1 whole square. We need to find the Nyquist plot of this control system. So for finding the Nyquist plot of the control system, let us substitute s is equal to j omega. Upon doing that, g of j omega multiplied by h of j omega is equal to 1 by j omega plus 1 whole square. Upon rationalizing the same with 1 minus j omega whole square, that is, upon multiplying and dividing by 1 minus j omega whole square, we see that g of j omega multiplied by h of j omega can be simplified as 1 minus omega square minus 2j omega divided by 1 plus omega square whole square. So from this we can say that at omega equal to 0 plus g of j omega multiplied by h of j omega is equal to 1 minus j 0, and as omega tends to infinity plus, we can say that g of j omega multiplied by h of j omega is equal to minus 0 minus j 0. Also we see that real part of g of j omega multiplied by h of j omega is equal to 0 for omega equal to 1 radian per second, and imaginary part of g of j omega multiplied by h of j omega is equal to 0 for omega tends to infinity radians per second. So from this we can say that at omega equal to 1 radian per second, the real part is 0. It means that the Nyquist plot intersects with imaginary axis at omega equal to 1 radians per second, and imaginary part of g of j omega multiplied by h of j omega is equal to 0 as omega tends to infinity radians per second. That is, the Nyquist plot intersects with the real axis as omega tends to infinity radians per second. From this, we can plot the Nyquist plot as omega varies from 0 plus to infinity plus as shown. At omega equal to 0 plus, g of j omega multiplied by h of j omega is 1 minus 0. That is corresponds to the point marked. And as omega tends to infinity plus, Nyquist plot value is minus 0 minus j 0. That is, it approaches origin through the third quadrant. And also it is given that Nyquist plot intersects with imaginary axis for omega equal to 1 radians per second. From this, the Nyquist plot can be obtained as shown. And also we know that the plot as omega is varied from infinity minus to 0 minus is symmetric with the plot corresponding to omega equal to 0 plus to infinity plus. And also we know that the type of the system is 0. From this we can say that the number of encirclements of Nyquist plot around the origin is 0. From this we can say that the Nyquist plot of the control system can be obtained as shown. Hence the correct option which corresponds to the Nyquist plot of the given control system is C.